Hello students and welcome back. We are doing the chapter magnetic effect of electric current, and in the previous class we understood that if a current carrying conductor is placed in a magnetic field, it will experience the force because that conductor will also start behaving as a magnet. And if the force will be given to that particular conductor, then in which direction the force will be given, that we can identify with the help of Fleming's left hand rule. That was already done in the previous class, and I hope you understood this much. Today we are going to talk about the next topic we have related with the same concept. But before we move to the next topic, one more thing is to be discussed, that if an electric charge is placed in the magnetic field and if it is in motion, it will also experience the force that we have already done. But what will be the direction of the force on that electric charge? We have done for the conductor, but we have to do for the electric charge also, and that can also be understood with the help of same rule we understood, that is Fleming's left hand rule. So let's do that very first. So in the note we can say that is force on electric charge in magnetic field. Okay, so by Fleming's left hand rule only. So the same rule will help us to identify, and will not have much discussion because we already understood the Fleming's left hand rule in the previous class. So just take an example. We have the magnetic field in this particular direction. So this is the direction of magnetic field, and perpendicular to this magnetic field, let a positive charge is moving. So let the charge is moving in this particular direction, plus Q. So if a charge is moving perpendicular to the magnetic field in upward direction and this charge is positive, then what will be the direction of force given to this electric charge? And for this we can again apply the Fleming's left hand rule. The only thing we should know, for the Fleming's left hand rule we need the direction of current, and we know if the positive charge is flowing upward, then we can say the electric current is also flowing in upward direction because the direction of current is taken as the direction of positive charge, that is the flow of positive charge. And now we can apply the rule. We got the current upward direction, we got the magnetic field this side, and again you can see my thumb is pointing towards the board. So we understood the force will be given to the electric charge towards the board. I will repeat it again. Current, C center finger, magnetic field, and thumb will show the direction of force. So according to this, the force will be inward. So we can take, this is one. So we can say force is inward and perpendicular to board. So you understood force is perpendicular to this surface, that is my board, and it is inward, that is towards the board. Okay. And second thing is, if the charge is negative, then what will be done? We know. So let's take the same, but take the negative charge this time. So if I say this is the direction of magnetic field and the negative charge minus Q is flowing in upward direction. So let it be electrons moving in upward direction or any negative charge moving in upward direction. Then what will be the force given to this charge, in which direction it will be given? So one thing we know, if negative charge is flowing in upward direction, we will take the direction of electric current opposite to the flow of negative charge. We understood in the very first chapter. So electric current is always having a direction opposite to the flow of direction of negative charge. So negative charge is upward, so electric current will be downward. And now we got the electric current, we got the magnetic field, so force is outward, you can say. So now this way, thumb is pointing towards you, towards my camera, current is downward, and this is magnetic field. So you understood, thumb is pointing the direction of force. So this negative charge will get the force outward and will remain perpendicular to the board. So we can say here the force is outward and perpendicular to board. So you can see positive charge inward, negative charge outward if the direction of magnetic field is same. I hope you understood. this is how we can apply the Fleming's left hand rule for the electric charge in a magnetic field, and we also understood how to apply for the conductor in a magnetic field. So I hope you will be able to apply this rule whether it is charge or whether it is a conductor. So now we are moving to the next topic, which is based on the concept of previous classes only. So I hope you are able to understand all the concepts, but still if you are finding any doubt, just let me know so that I can help you anywhere. Okay, so the next topic we have is electric motor. So you might have seen electric motor at many places, whether you see your fan, whether you see the vehicles, in the wheels also, in the tires, within the wheels we have the motor only, within the fan we have the motors only, and lots of machines we have which are having motors. And those motors are basically working on some principle, and that is what we are going to understand, means how the electric motor works. And the very first thing is to know, overall when we have an electric motor, that needs power. So you give electric power to the electric motor, and in return what you get the rotation. So the electric motor has nothing but a kind of rotation, which is nothing but a kind of mechanical energy. So electric motor is nothing but which is taking the electric energy from somewhere, and then in return you are getting the rotation, means there is some mechanical energy. So any part which is having a motion, that is basically having mechanical energy. So we can say in brief, the electric motor basically converts the electric energy into mechanical energy, and that is the only definition we have for the electric motor, that is a device which converts electric energy into mechanical energy. So even within your washing machine, you see there is a kind of motor only. There are lots of places. Okay, so I hope you understood. Any electric motor, I cannot draw that much, but in brief, you know, the electric motor look like this, and it has a part which rotates, and it will have two different terminals, positive and negative. So finally, this will have the rotation when the power will be given. So it will consume the electric energy, and it will give the rotation that will have mechanical energy. So electric energy will be converted into mechanical energy, that is the working of a motor, and this is how we define the electric motor only. I hope you understood the definition. And now it works on the very simple concept that we have already understood in the previous class only, that is, if a charge so principle of the electric motor, that is, it works on what concept? And it simply works on the concept that if a conductor is having current and it is placed in a magnetic field, this conductor will experience the force. That we have understood in the previous class only. A current carrying conductor, when placed in the magnetic field, experience a force, and that is nothing but the principle of electric motor, or the working concept of electric motor. So you should know this much, and then you will have the working and explanation very soon. So we can say that is the current carrying conductor experiences force when placed in an external magnetic field. So this is what we have done in the previous class, that was the topic, and now this is the principle also for the electric motor, that is working principle. So I hope you understood, but it will be more clear when we will understand the working of the electric motor and the that will be done with the help of the diagram, and I'll demonstrate something which will help you to understand the concept. So after the principle we have the diagram, and then we will go for the working. I hope you will be able to understand the concept. So diagram, first let me show you something, then I'll draw. So for this I'm just taking the help of something. Just take an example. We have a kind of rectangular board, and that can be a conductor, that can be the iron core. Okay, so just imagine we have this material made up of iron only, and over this, that is at the boundary, there are different turns of the wire. So you can see I've just given one turn of the wire, but there can be many turns. There are lots of turns, 1000, 2000 turns of the wires will be there, and that will be the insulated wire the way I have taken. Okay, so overall we have a rectangular iron ore or iron core, we can say, and that is having the different turns of the wire at the boundary. Okay, and this wire will finally have two different terminals that you can see here, and these two terminals will be connected to something that I am going to show. So overall we have a rectangular coil. So it is a kind of coil only because we have given different turns of the wire, and this coil is placed between two different magnets. So one side will have one magnet, one side will have another magnet, such that the one magnet will have the north pole one side, another will have south pole. So this coil will be placed between north and south poles of two different magnets, so that between the two magnets there will be magnetic field, and this coil will be placed within the magnetic field. Okay, so very first I am going to draw the diagram, then it will have more clarity and more concepts. Okay, so what we have, a rectangular coil. So let me draw here. Okay, rectangular coil we have. Okay, I have also given the name A, B, C, D, and this will help you to understand the working also. So let this be A, B, C and D. It will have two different terminals of wire which is having a turn over the, which is wrapped over the ore. Okay, and then this is placed between two different magnets. So one side we have one magnet, another side we have a different magnet. Okay, so this is a north pole, for example, this is the south pole. So this is your magnet with north pole this side, and this is another magnet with south pole this side. So you understood the south pole of this will be this side and north pole will be of this side. And finally these two different wires which are coming out are given the support, and this is connected with the help of a ring. I'll demonstrate this also. So just imagine that this wire is so rigid, it's not like this, it will be given a proper support with the help of some rigid material, and then this wire will be connected with one half ring this side and half ring this side. Okay, so the ring I cannot show now, but you can see in the diagram. So the wire which is coming out is finally connected with a half ring this side and half ring this side, and these two half rings are basically made up of conductor only and without any insulator. So we can say this two conductors are not having any kind of insulator over its surface. Okay, but the wires are coming which is finally connected to the ring. So this is one thing you should know. And then finally these two are in connection with something. I'll let you know this also. And this is finally connected with the power supply with the battery. let a switch is there. So diagrams look very odd, but you need to understand the concept and you'll be able to relate also. So we got a rectangular coil which is nothing but made up of iron, and then over this iron we have different turns of the wire, many turns are given. So overall we are somehow trying to make the coil-like structure a kind of electromagnet, and these two wires which are coming out, that is the two different terminals of the same wire, will be given the support, and finally this will be connected with the help of two different rings, half ring this side and half ring other side, and this is also called split rings. Why split? Because it is half and half at one side, so we can say one ring has been split into two, so half ring and half ring, it is called a split ring. And finally the ring you see here is connected with two different carbon brush, so I am giving the name, let it this be X and this be Y. So X and Y are your carbon brush. Carbon brush is nothing but a conductor only, okay, which will remain in touch with the ring, but there is no permanent connection. Permanent means the ring can move freely, so there is no problem in the rotation, and the carbon brushes X or Y are just in contact with the split rings. Okay, so you have to imagine this way: if this is the wire, then half ring will be this side, this way. So this is connected with the half ring and this is connected with the half ring, half ring both the side, and then finally that ring is connected with the carbon brushes X and Y. Okay, and that is finally connected with the power supply with a switch. So this is all the construction we have. I am repeating again: a rectangular coil having different turns of the wire are connected with two different split rings, and let the name of the split ring is P and Q, so that you'll have understanding in the working. And these two split rings are finally connected with X and Y, which are nothing but carbon brush, which is also a conductor, and that carbon brush is finally connected with the battery with the help of switch, so that we can switch it on and off. So I hope the construction is clear. So this coil is given the name called armature. So the coil we have at the center is called armature. Rest you understood. P and Q are your split rings, okay, and rest you understood. The magnets are there. So overall these are the different parts of the electric motor. I hope you understood. Maybe you are facing problem only with the split ring. I am repeating again: if this is the wire, then split ring will be this way. So I cannot show in the diagram, but the split ring is half this side and half this side, and the battery is here, and this split ring and other split ring is connected with the carbon brush. Okay, that is all the construction we have. That I can't demonstrate that much here, but I hope the diagram is clear. And now if the diagram is clear, we can understand the working. So till now we understood electric motor is a device which converts the electric energy to mechanical energy. It works on the concept that whenever a conductor which is carrying a current is placed in a magnetic field, it will experience the force. Diagram I have already drawn here, and now let's understand the working. So for the working we just need to take the help of the Fleming's left hand rule. If you understood the Fleming's left hand rule, you will be able to understand the working without any difficulty. Now the very first thing is, we know if you have north and south here, we know the magnetic field will be from north to south. That is the direction of magnetic field all the time. So here we can say the magnetic field is from this to this direction. So this B and this B, they are not same. This B is for magnetic field and this is the name given to this coil, ABCD. Okay. So this you have to remember, the magnetic field is in this direction. Now once the switch will be on, what will happen? The current will flow. Now since the current will start flowing, this carbon brush will allow the current to flow. This carbon brush will finally give the current to the split ring. Okay, because split ring is not having any insulator over it. And finally this split ring will transfer the current to the coil. So the electric current will move to the coil and finally it will come back. So this is the current flowing in the coil. I hope you understood. So this is your electric current. So once the switch is on, the electric current will start flowing from positive to negative, from the battery to the carbon brush to the split ring, and then it will finally go to the coil, and then it will come back to the other split ring and to the battery. That is how the electric current will flow in a particular direction. Now let's understand the working. So we can apply the concept that if overall this is the coil which is having different conductor, that is the conductor is there, nothing but the wire itself, and we know if the current will flow through this wire, this will also get magnetized and it will start behaving as a magnet. So if you concentrate on AB, if you concentrate on CD, we can imagine two different conductors having the current and it will experience the force. So for AB and CD, we can apply the Fleming's left hand rule and we can identify if this coil will get the force, then in which direction it will get the force. Am I clear? Based on this, we can find out what will happen to this coil finally. So for this AB, what you see, current is upward and magnetic field is from north to south, so this is toward this direction. Current is upward, so thumb is pointing inward, so this part AB must get force towards the board. So I am doing this way, so this will get the force, let it be F1, that is towards the board. And now if you concentrate on CD, the current is downward in CD portion, magnetic field is still in this direction, that is north to south, and thumb is pointing outward. So this part will get force upward. So this is your F2. What will happen? Finally this coil will rotate. So this will happen. This is the structure. This portion is getting force inward, this portion is getting outward. So what will happen? It will get the force. And once it will get the force upward, downward or outward, inward, it will rotate. I hope this part is clear. So finally half rotation is done. Am I clear? And when the half rotation will be done, what will happen? The split ring will also change the position. So very first you should know the split ring is capable to move freely. Am I clear? Along with the coil. So when the coil will move, the ring will also move. So the ring attached here will go to other place, which the ring will continue to move along with the wire. So with the wire, the ring will also change the position. So I hope your half part is understood. This AB is getting inward force, CD is getting outward force. So finally it will rotate. And now this will be the new position of the coil. AB will go to this side and CD will come opposite. So let me draw the next part. So after this half rotation, your coil will be shifted because your position will change. So we understood, after half rotation what will happen? CD will come this side and AB will come this side, and the ring will remain with the same. So with AB, what ring we have? P. So P will come this side and Q will come this side. So along with the AB and CD, the ring will also change the position. And now this will come in contact with the carbon brushes. But carbon brush will not change the position because that is fixed. So this is X and this is Y. I hope you understood this much. We started with the electric current. We applied the Fleming's left hand rule and we understood it will rotate half. After half rotation, we'll have the new position of the different parts of the coil. So the AB which was in my left hand side, now it has been shifted to my right hand side, and CD will be opposite. So they have interchanged the position, and the split ring will also change the position along with AB and CD. But carbon brushes are fixed. Battery is fixed. This part will not move, center part will move. So this coil and this ring will rotate it is free to rotate the way it is done, or the setup has been done, but the rest part, that is carbon brush and the battery, will not move. That is how the setup has to be done. Now after half rotation, what will happen? The current will remain in same direction, because positive is now this side, negative this side, same like the previous case. So the current will move in this direction now, I. So I will be this and I will be this. I hope you understood. Now you can see CD is having current upward, magnetic field will remain same direction, B. Okay, so what will happen to the CD? So magnetic field here, current is upward, thumb is pointing towards board. So this CD will get the force inward, and now AB is having current downward, magnetic field this side, thumb is outward. So this will get force upward. So what will happen? In the previous case also, this coil was moving this way, and after half rotation also, now CD is going down only and AB is coming up. What will happen? Again, and this will continue. So what you see, finally the coil will rotate in same direction throughout. That is the working of electric motor. You might have seen the electric motor, the rotation part we have is basically in the same direction. That is how with the coil what will happen, the ring will rotate, and this ring can be attached with any kind of insulator which can rotate along with the ring, and that is what you see, the rotation. So you cannot see the split ring, you cannot see the armature of the motor. What you see finally, that is a portion of the electric motor. So if you have electric motor which is connected with positive and negative, you do not see the inner part. What you see, this part is rotating. So what you see is this, which finally rotates. Okay, so along with this split ring, we can attach a cylindrical structure which is insulator, so that it can start rotating. So that is how the working we have. The split ring is connected with a cylindrical structure which starts rotating along with the ring. So throughout this process, when the current will be flowing in the circuit or flowing through the electric motor, it will continue to have the rotation in one direction. And we understood, if you reverse the battery, positive and negative will get interchanged, their rotation will just get reversed. And you know, in the motors that is the case. In the same motor, the rotation can be in clockwise or anti-clockwise direction, depending upon whether you connect positive here or negative here. And in general, the electric motor can give you rotation in both the sides. So positive and negative can be interchanged. So I hope you understood. I am repeating once again. Overall, it looks complicated, but still, if you try to analyze with the help of some working model, then it will be more clear. And once we see the real working motor, then it will have more and more clarity. So I am repeating again, overall electric motor is working on the principle of the concept that we have done, that is the conductor which is carrying current gets the force in the magnetic field, and that we understood with the help of the Fleming's left hand rule. That is, only with the help of Fleming's left hand rule we are able to apply the concept here, and we are able to get the direction of rotation of the coil within the magnetic field, and that is how we are able to get the motor. So I hope you understood this much, but still you have any doubt anywhere, you can let me know. But I cannot write this much on the board, I cannot write on the working here that much, but still you can try yourself. The only thing is to be taken care, if my coil is on the surface of the board, then it is understood the current is upward, current is downward, but the force will be inward and outward. So use the word inward and outward for the direction of force. Use the current direction upward and downward, or you can also use the concept like the current will move from B to A, the current will move from C to D, and vice versa. Okay, so that is how the working has to be written, and that is to be done by you. Try to do it yourself, and I hope you can do if you have really understood. And if you have not understood, go through the lecture again so that you can revise, and finally you can analyze. But the thing is, you need to imagine, because this is something which is three-dimensional picture. I cannot demonstrate the entire picture here, so I am taking the help of just one structure so that you can just see how AB and CD will change the position. But still, the rotation of the coil will remain in one direction. So that is all we have today. I'm not going to the next topic because already it's quite lengthy concept. That is, we need to understand the principle and working, and you need to do the work yourself. And once you have done this work, then we can move to the next topic of this chapter. And I'm repeating again, if you are finding any problem anywhere, just let me know so that I can help you in this topic as well. And for today is done. Thank you. Take care and Hari Om.